Hi, and welcome to this short video demonstration of the ModuleWorks real-time collision avoidance system on a Siemens 840D SL CNC control. Part 1 shows the simulation in auto mode without collisions. The part you see is a spiral mandrel distributor which has been programmed in a CAM environment. It is running at 10 times the normal speed in the first part of this video. The ModuleWorks collision avoidance system features full scene collision detection with look-ahead functionality, which you can see through the transparent tool. The look-ahead is always shown relative to the workpiece in auto mode, but of course, collision avoidance protects the entire machine. The look-ahead time can be freely configured by the OEM machine tool builder. In this case, it is 800 milliseconds. If the collision avoidance system, or CAS, issues a stop signal, the machine is stopped along the trajectory in auto mode. The machine stopping time is also configured by the OEM. In this case, it is 400 milliseconds. Now let's take a look at an actual collision situation in auto mode. Let's restart the CNC control and take a closer look at the first part of the program. As you can see, the clearance between the tool holder and the fixture is very tight. There is no collision yet, but it's close. So what happens if we now enlarge the tool holder? Here in the Job Setup view, we will replace the current tool holder. Currently, holder 14 is selected. Let's choose an enlarged holder. Look closely at the 3D view as the selection is made. As you can see, the holder has become wider. Now, let's rerun the same program. The lead-in motion is still safe, so the beginning of the program shows the same behavior as before. But, as the tool starts cutting, the 3D model turns red and the program stops immediately. Although the real position of the machine is still safe, the look-ahead position interferes with the preset safety area of 3 mm around the fixture. This value can be freely configured, and you can even have different safety areas around different objects. If we rotate the camera and take a look from behind, you can see what actually happened. The visualization shows a very tight gap between the holder and the fixture, and this is what caused the machine to stop. As long as there is no collision or safety area violation, the machine process is not modified in any way. Let's take a look at how collision avoidance works in jog mode. In jog mode, we follow a different strategy. Let's take a closer look. To get a better understanding of what's going on, you can see a machine control panel on the left side that shows which buttons are being pressed. As the Z-axis is jogged in rapid mode, you can see how the maximum feed rate is actively controlled by the collision avoidance system. As soon as the look-ahead position reports a collision, the feed rate is reduced by half to allow further movement. This results in the red flashing that you see. As we move around the workpiece, you can see the actual machined workpiece model is taken into consideration. This allows you to get very close to a collision without ever actually causing one. In theory, the machine operator will no longer need to keep a second hand on the feed override knob, increasing the machine's productivity. So far, we were jogging individual axes. CAS also supports jogging in the so-called triary mode. This is where the machine is moved in the workpiece coordinate system, and multiple physical axes can move simultaneously. Jogging in triary mode can be tricky because it quickly becomes confusing to see which axes will actually move in which directions. This makes CAS very valuable in triary mode. Because the look-ahead position is calculated by the CNC, the current modes are taken into consideration, which enables the CAS to avoid collisions just as in regular jog mode. So, we have seen how CAS behaves in different operating modes, but one question remains. How is CAS fed with the actual 3D tool geometries and workpieces? The answer is job setup. Before diving into the details around job setup, let's take a look at the data that is already available today on the CNC control. Most importantly, the tool definitions in Operate, the Siemens HMI. Operate already includes some key tool parameters, like the cutter type, overall tool length, also called overhang, and the tool radius including wear offsets. Additionally, the OEM parameters such as flute length can be used to create a more detailed description of the tool. All of these parameters are fully synchronized with the CAS system through OPC UA. When a parameter is changed, the CAS system is notified automatically. So while Operate already defines some of the needed data, things like tool holder geometry are missing. And that's where job setup comes in. Job setup is part of the CAS system and allows the operator to define further 3D geometries, such as tool holders and adapters, as well as fixture and workpiece geometries. Let's take a look at a concrete example, an angular head. This is defined as an adapter inside job setup and has been imported from an external STL file. The angular head is assigned to the spindle, and once it is activated on the CNC, the 3D model including the needed kinematic transformations is also activated in the CAS. We hope you enjoyed this short video. If you have any further questions about the ModuleWorks collision avoidance system, please don't hesitate to get in touch with us.